This is Dare Sites. This video demonstrates a selection sort. Here in the scene editor of the Alice programming environment, we see 9 biped objects lined up in no particular order, and the selection sort will sort them according to height, with the shortest on the left and the tallest on the right. This turtle character serves as the leader of this group of bipeds. First, let's watch the animation. The turtle announces to line up by height. Notice the smallest ones are coming from the right side down towards the left. We're going to run that again and watch how the smallest characters move one by one from the right side down to the left. So on the first pass through this group of characters, the smallest one will become the first one, and the next pass, the next smallest one will move to the second slot. Let's watch it again. We'll restart. Smallest one is the rabbit. It's going to move down. The next smallest one will be this toy tiger. And you can see the panda. And then these are already in position, so there's no moves there. And the turtle says, "Nice work." Let's look at the code now. Here in my first method is the main flow of the program. There's an initial delay. The leader gives the command to line up. A procedure named selection sort is called. That's where the main programming logic is. A final delay, and the leader finally says, "Nice work." Before looking at selection sort, if we go to the scene class down at the bottom, there are 2 arrays being used. A bipeds array, which contains the 9 bipeds that we see in the scene, and an object markers array. The object markers appear in the scene as the axes, the 3-dimensional axes that mark the locations where the bipeds initially stand and where they will end up standing in those same locations after they're sorted. Those are called object markers. You can see them in the scene editor, but they're invisible during the animation. Next, we'll go to look at the selection sort procedure. At the first statement, it sets up a variable called array length and gets the length of the bipeds array. Both the arrays are the same length. Then it uses an index to index into the array initialized to 0. A while loop is going to loop starting at 0 based on the loop variable index as long as it's less than or equal to array length minus 2. Inside the while loop, the first statement is to get the smallest height index. This is a function that will look through the array of bipeds that's currently sorted array and find the smallest height biped in there. And we'll see that it doesn't start at the beginning every time. It takes, if we look here, a starting index parameter. So it passes the bipeds array, and it also passes where to start looking, because as we see as this algorithm progresses, the smallest bipeds are one by one being moved to the left side of the line. And so the search for the next smallest needs to progressively look through the unsorted portion of the array, which is on the right side. There's a sorted portion on the left side and an unsorted portion on the right side. After it finds the next smallest one and puts the index of that in smallest index, it does a compare to see if that smallest index is the current index. If it's not the current index, then it needs to exchange the smallest one with the current one. If it is, then there's no move necessary. It just turned out in that case that the current biped is in its right position in the sorted array. But if we do need to exchange a smallest with the current, we go into this if statement here. The comment says first to swap the bipeds in the scene, the actual movement in the scene of the two bipeds. There's a leftmost biped and a rightmost one involved in this swap. In this code, the left biped is the one at the current index, the right biped is the one found at the smallest index location. The left marker is the corresponding object marker at that index, and the right marker is the corresponding object marker at the smallest index. Then a do together statement, which means these two statements will happen simultaneously. The left biped will move to the right marker, and the right biped will move to the left marker, giving a duration of 2 seconds for these moves. After that, finally, the actual bipeds in the arrays have to be swapped in their positions. And to do that swap requires a temporary variable, temporary biped. The left biped is assigned to that temporary variable value. Then the current index is replaced with the right biped, and the one at the smallest index is replaced with the temporary one, which was the left one. Finally, at the end of the loop, the loop index is incremented by 1. That means the remaining procedure to look at is this get smallest height index. That is defined in the scene class, and here it is. It takes the array, which is the biped's array, as a parameter, and a starting index. It starts with a smallest height variable initialized to a very large value that no biped will ever have, 9,999. It initializes the smallest height index, which is what it's looking for, to 0. That will be changed by this procedure anyway. Then it has an index to go through a while loop, and that index starts at the starting index that was passed into the procedure. The while loop begins at that starting index and continues as long as it's less than the length of the biped's array. Inside the loop, we obtain the current biped in a variable called biped, and get the height of that biped in a variable called height, and compare that height to the smallest height we've found so far, or the initialized one that's very large. And if it's less than, then we take that height and it becomes the new smallest height, and we take the index of that height and it becomes the new smallest height index. At the end of this while loop that's looking through trying to find the smallest biped in the unsorted section of the array, we increment the index by 1 to continue looping, and when the loop is finished, we return the smallest height index. Let's view the running of the animation one last time. Line up by height. That one, the next smallest, number 2, the third smallest. 4th, smallest, 5th and 6th are already in position, 7th, 8th. Finally, they're all in order. That is a selection sort algorithm.